All right, now we're going to look at a very special type of application of the fundamental theorem of calculus of the Riemann sum and area. These are table examples, and actually the only way you can solve them is using your Riemann sums, is using those area under the rectangle sums. All right, so what we mean by a table example, so if we're given an application where we have table values, so this one represents the rate of sales, all right, which rate means derivative, so we can find how fast cell phones are selling, right, the speed at which cell phones are selling, t days after they've been released. And you'll notice, so this represents the number of days, this is the rate of sales in phones per day, and you'll notice 10 days, so the first day there's 60 phones per day is how fast it's selling. 10 days later, 45, 20 days later, 32, and so on. And so again, you'll notice this rate of sales goes down as it gets to 50 days. We plot these points. So again, those are the points that we have. So if we plot these points, so here I've graphed it already for you in your notes. So this was in the notes. So this was the time 0, which would be 0 days. This would be time 50, which would be 50 days later, right? This would be my days. The Y value is the rate of sales in iPhones per day. And so if we were looking for the exact area, we would find this area here. All right, so this area would represent, right, because if we take rate of sales in phones per day, that would be the height of the area, the length of the area would be days. The days would cancel out, and so the area would represent the total sales of the phone over the 50 days. Right, that's what that area, if I found this area, that's what that area would represent. All right, so it would estimate the total sales of the cell phones over the initial 50 days. All right, well, how can we find this area? We're not even given a function this time. We're just given points that I've plotted. So how do we find the area? Well, the only way that we can do this is using the Riemann sums. And so remember, there's the Riemann sum, we can either draw the rectangles from the left or the right points. And so we'll do that in the next pages. We'll find the estimated sum using the left points, the left part points, and the right part points. All right, so we'll do that in the next one. So the first example is, so suppose I want to estimate the area using the right side. So it means I start from the right, right? My rectangles would be drawn over 0 to 50 using each of my points. So if I start on the right side, I start here at 50. This is where we start, because I'm on the right side. And so I would go up and hit my first point. Well, that first point is at 50, 18, right? 50 days, 18 was the rate of sales. And then I would go, if I could draw a straight line, that would be fantastic. All right, we draw straight over and down, and there would be my first rectangle. All right, then the next rectangle would be at 40. So I'd go up to the dot at 40. So remember, this was 40, 22. 40 days, 22 was my rate of sales. So I go up, I'm at the dot, and then I go over, and there's my second rectangle. My third rectangle goes up at 30. So to the point 30, 28 was the sales at 30. And then I draw that over, and there's my next rectangle. And then so on at 20, I go up to the dot at 20. So that was 20. 32 was the point. Draw it over. 10 would be the next one, would be the last one. Actually, this would be the last one because it stops at my axes there. And so 10.45 was the rate of sales after 10 days. And so if I find the rectangle area, so this would be rectangle 1, rectangle 2, rectangle 3, 4, and 5. So remember, the area of the rectangle is base times height. The height is the Y values in the points that we use. The base is the width, the change in X. Well, you'll notice the width in each one of these is 10 units, right? We go over by 10 units in each one of these. And so the width is 10 units. All right, so each rectangle we multiply by 10. So I'm actually going to do that. Well, you can do it within or less. It really doesn't matter. And so this one, and you'll notice if I kind of draw a dotted line through the points, you'll notice that this is going to be a low estimate because I'm missing those top areas. So this is going to be my low estimate. If I can spell estimate. Low estimate. So I know that the actual area should be bigger than this, which means probably when I do the right side, sorry, the left side, it should be a high estimate, but we'll see. All right, so we're going to find the area using the right rectangles. And so we're going to take rectangle 1 plus rectangle 2 plus rectangle 3 plus rectangle 4 plus rectangle 5. The width of each rectangle is 10. The y values give the heights, right? The height of this first rectangle is 45. The height of the second rectangle is 32. The third is 28. The fourth is 22. And the fifth is 28. And so when I use my right Riemann sum, area of the rectangle 1 is going to be 10 times 45, right? That's the height. Rectangle 2 is going to be 10 times 32. Rectangle 3 is going to be 10 times 28. 4, if I can squeeze them in there, 10 times 22. And the last one, 10 times 18. I'll squeeze it in there. Again, you could do this 10 times the sum of all the heights, which would be 10 times 45. Oops, not 44. 45. Plus 32, plus 28, plus 22, plus 18. And that's probably, if I were simplifying it, that's the way I would do it. Then I'd only have to multiply by 10 at the end of the problem. And so the right approximate area comes out to be, when you add up all those values, it comes out to 145 times 10. And so the right area is 1,450 is the approximate area, which would be the approximate low estimate in sales. All right, so that's the right Riemann sum. So we do the exact same thing on the left side, but we use the left. So we start on the left side, all right? So we're doing the left side. So we're starting here. The left side starts at 0, right? The 0 is the leftmost point, right? This point up here is the leftmost point. And so when I draw my first rectangle, I start at 0. I go all the way up. If I could draw a straight line, that would be wonderful, but apparently I can't. All right, going up on this line, hit the first point, which is at 60. All right, sorry, 0, 60. Forgot my 0. 0, 60. And then my first rectangle would go through there, and then the next rectangle goes up to the 10, 45. The next one starts at 20, 32. And the next one is at the next point, which is at 30, 28. Goes through that point. The next one goes over. And actually, that's the last one because that ends here at 50. But it's at the point 40. So we stop at the point 40. 22 is the last point we use. We don't use the 50 because the 50 doesn't make another rectangle, right? This is my edge. I stop at 50. All right, so there are my 5 rectangles. So rectangle 1, rectangle 2, rectangle 3, rectangle 4, and rectangle 5. The width is still 10, so the width is still 10, right? That's the base. The height is still the y values from each of the points, from the points that we used. All right, so again, we're going to do the left sum to approximate my area. So using the left Riemann sum, it's going to be each one of my rectangles. And again, this time it's going to be a high estimate because if I draw a dotted line through my points, right, there's my last point, I'm a little bit above. So this will be a high estimate. All right, so again, each one of my rectangles is 10 units wide. It goes by tens. And so it's going to be, and this time again, I'm going to just write 10 on the outside because I think it's easier to do that. It would be 10 times all of my heights. So it's going to be 10 times 60 plus 10 times 45, 10 times 32, 28, and 22, right? Because those are the heights. Those are the values that we use for the height. 22 at the end if you can't read it. 22. And so then this will approximate my area. So it's, when I add it up, this is 187 times 10. So it's 1,870 is the high estimate for area. Now, if you'll notice, using the two values, we actually interchange the end rectangles, right? That's what we do. And so, oh, no, cancel. That's not what I wanted. I wanted the highlighter, yeah. So you'll notice here, these rectangles, these four rectangles, between, I guess I should go to the points. Oops. Oh, I hit the button. Sorry, guys. Give me a second while I get back to it. Basically, we use why it won't draw my highlighter now. Alright, well, we'll draw my pen. These four rectangles are the same as these four rectangles. All we do is change the last ones. Right? You'll notice in here that 45, 32, 28, 22 are used in the right. The same thing over here, 45, 32, and 22, 28, 22 are used again. What we do is we switch the leftmost one with the rightmost one, and that's the difference between the two. And so a lot of times that's sort of what we can pay attention to when we work these problems. All right, so the last thing, so there's my left area, my right area, right? That's not my final answer. All right, what we do is, well, again, the actual number of sales, so sales for phones over the first 50 days should be less than the 1,870, greater than the 1,450. And so since I know sales should be in between there, what they usually do in marketing when they do this is they average the two. All right, so the average between the low and high value, will you add them up and divide by 2. All right, and so when you add them up and divide by 2, that comes out to 1,660. So this would be our best guess. We would guess that we would estimate that about 1,600 phones are sold in the first 50 days at this particular store. All right, based on sales. Based on the rate of sales, that's what we would estimate. All right, so we're just going to practice that in a few more problems. All right, and I'm actually not going to graph these. All right, so again, look at the previous examples. We'll do the Riemann sums with tables. So this is just a generic one where we're given the function t 3, 6, 9, 12, 5. This would be my rate of change. 32, 25, 21, 15, 10, whatever it means. Again, it doesn't have any meaning in this context. I didn't give it meaning. So this one, we're just practicing finding the areas. All right. And so what we have to do is, well, we have to figure out what are my left points, right points, and what are my widths. My widths are the same. So we want to find the left-hand, right-hand sum of this function between 3 and 15, because that's my starting and stopping values. Again, it's continuous and positive between those values. And so the first thing we have to do, figure out the width, because the width is the same for each of them. The width would be the change in x or the change in t in this case. So it means if I draw my rectangles, they'd be drawn between all of those points. Well, what's the distance between each one of those points? I go 3, 6, 9, 12, 15. Well, the width is 3. Each one of my rectangles, if I drew it, I'm not going to draw it in this case, but if I drew it, each one of them would have 3 units between them. All right, and so I have to remember this. The y values are the heights, which would be these values. And again, depending on where we start. So if I start with my right side, right hand. So there are 4 rectangles, right? This would be rectangle 1, rectangle 2, rectangle 3, rectangle 4. And so all I have to figure out is, what values do I use for the heights if I'm on the right side? So if I'm on the right side, I'm going to use this red color for the right side. I would start drawing it up at 10. 10 would be the height for the first rectangle, 15, 21, and then 25 would be my last height, because I would draw it here and it would be my last height. So I would go 10, 15, 20, and then 25 would be my last. And so on the right side, those are the y values that we use on the right side, right? We don't use the 32, or that would be on the left side. And so I just use that fact. I know that each of my widths are 3, so the right side is going to be 3 times each one of those heights. So 3 times the 25 plus the 21 plus the 15 plus the 10. And so I add those up. Don't forget to multiply by 3. Again, a common mistake students will make, they'll figure out the heights, but they'll forget the width. Don't forget the width. And so it's going to be 3 times whatever those values up to be. So 3 times 71, which comes out to 213. All right, now the left side. So I'm going to pick a different color for the left side. We'll do, I have a lot of colors here. Orange, we'll do, yeah, maybe we'll do blue. We'll do blue for the left side. All right, so the left side. Oops, left side. All right, so then 3. So I'm going to put 3 down so I don't forget it. 3 times what are the heights from the left? So if I'm on the left, right? Left, I start here at 32. So I would draw up at 32. The next one would draw up at 25. And then up at 21. And then up at 15. 15 is where we would stop. We wouldn't draw another one at 10. And so the 32, 20, and again, the middle one should always be a part of it. We just switch where we start the ends, right? We either start on the right side, and that one is included, or we start on the left side, and that. So this one's the left side, so we include 32. 32 will be the first rectangle drawn. So 32 plus 25 plus 15 and plus, oops, forgot 21. So plus 21 I'll put in there. All right. And so again, the other check is to make sure you've got the numbers right. Is there, if I've drawn my rectangles up here, there's only 4. So there should only be 4 numbers that we add together, right? 4 rectangles. And so those are the 4. So I add up those, which those add up to 93. 93 times 3. Don't forget to multiply it times 3. 279. So 279 would be my high value. So the actual area should be less than 279, greater than 213. So it's between those two values. And so what we usually do is we usually find the average. So you take your 213, 279, divide by 2, and the average is about 246, would be the approximate area. So for this particular application, between 3 and 15, the area is about 246, whatever that would mean in this application. Again, I didn't give any meaning, we were just practicing it. All right, the last example. All right, this is one that actually shows up on a final exam. This is a question I pulled from an old final. All right, so again, it's a table example. We're given rate of sales, and I have to remember it's in hundreds of dollars. So my final answer should include the hundreds of dollars. T represents days, 0, 7, 14, 21, 28. So I'm going by sevens. This is the rate of sales in hundreds of dollars per day. So this is how much money they made each day based on their rate of change, their rate of growth. All right, so that's the dollars per day. Use the Riemann sum left and right to find the total sales. Again, we're going to use the estimate on those. So if I were to draw my rectangles, they'd be drawn between 0 to 7, 7 to 14, 14 to 21, 21 to 28. So there are 4 rectangles again, right? Rectangle 1, rectangle 2, rectangle 3, rectangle 4. The width is 7, right? Each one of those, there's 7 units between each rectangle. And so I can't forget that. The width is 7. All right, then I figure out my left and right sum. So we'll start with the right sum. All right, so using the right sum, don't forget 7. So I'm going to go ahead and write 7 down. And I want the right height. So if I'm on the right side, I start here. So my first rectangle would be drawn up at 42, then 36, then 55, and then we draw the last one at 48. And so those are the values we use on the right side. 48, 55, 36, 42, and then don't forget times 7. So we add those up and multiply by 7. So when we do that, that comes out to be 1,267. Remember, it's in hundreds of dollars. Just remind myself it's in hundreds of dollars, so I get the final answer. All right, so that's the right, which again, at this point, I don't know if it's a high estimate or low estimate, although based on my numbers, I'm going to guess that's my low estimate because I'm going to change 42 and 45. So actually, left and right's not going to be that much different. There's only a 3-unit difference. All right, now the left side. All right, left side. So 7, I'm going to put it down here so I don't forget it. So on the left side, we would start at 45. Draw the first rectangle, then 48, 55, and then we would stop at 21. 21 would be the last drawn rectangle because we don't go at 28 because that would make us another rectangle over. All right, so we stop at, sorry, it's the value 21, which is actually 36. So those would be the values I used for the left. Remember, the middle numbers are always included. We're just changing. So left and right in this case aren't going to be that different. They're going to be off by 3 units in the height, 3 times 7, so they're going to be off by 21 units total. We use for the left 45, 48, 55, 36 is the heights. And then don't forget to multiply by 7. Again, the most common mistake students forget is they forget to multiply by the height. Alright, so 7 times those numbers added together comes out to be 1288. So this would be the high estimate. This is the low estimate. We want to find the approximate. So again, sales would be somewhere between 1,288 and 1,267. That's where it would be between in hundreds of dollars. We find the average, which we take our 112.67 plus our 112.88, divide by 2. That comes out to 1,277 and a half. So remember, that's in hundreds. You either use the word or you multiply by 100. So they would have about, because it is an approximation, 1,27750. So $127,750 in sales, which would be revenue. All right, based on the number of information given. All right, so like I said, this is a special type of application if we're given table values. All right, so table values. All right, we'll wrap it up there.